All right, today we are diving into a really fascinating, kind of mind-bending idea that could totally challenge how we see the cosmos. It's called pressure-mediated gravity, and it offers a completely new way to think about space, time, and, well, pretty much everything that holds the universe together. So let's just kick things off with a pretty wild question, one that gets right to the heart of this huge cosmic mystery. For decades now, right, we've been told the universe is mostly filled with this invisible stuff, dark matter. But what if that's not the whole picture? What if the problem isn't that we're missing some kind of matter, but that we've got gravity itself wrong? Okay, so to even begin to understand why you'd ask a question like that, we've got to zoom in on this, well, this weird tension that's happening on a galactic scale. There's this stubborn anomaly out there that our best, most trusted theories are really struggling to explain. And here is the heart of the problem. You see, on one hand, our standard model of cosmology, it's amazing. It's brilliant at predicting the universe's huge cosmic web structure. But when you zoom in on individual galaxies, it just hits a brick wall. The issue is pretty straightforward. When you count up all the visible stars and gas, galaxies are spinning so incredibly fast, they should have just flown apart ages ago. So the solution we came up with was to invent this giant invisible halo of dark matter to provide the extra gravitational glue. But, and this is a big but, look at that graph. That's called the Baryonic Tully-Fisher Relation. It shows this ridiculously tight, super predictable link between a galaxy's visible stuff and how fast it spins. And that's the real puzzle. And here's the rub, right? It's a big one. This super tight relationship, this lockstep connection between what we can see and how fast a galaxy spins, that's something that dark matter models have a really hard time explaining. I mean, if dark matter is this totally separate invisible thing, then why is it so perfectly tied to the visible matter? It feels like a massive coincidence. It's almost like the visible stuff we can actually measure is calling all the shots, dictating the entire dance of the galaxy all by itself. So this brings us back to that first question. What if the solution isn't to just keep adding more invisible stuff? What if it's about completely rethinking the nature of space-time itself? Well, this is where this new idea, pressure-mediated gravity, or PMG for short, walks onto the stage with a seriously mind-bending proposal. What this framework suggests is that the vacuum of space, it's not empty at all. Nope. Instead, it behaves like a really special kind of fluid, something called a superfluid. Just try to imagine a liquid that has absolutely zero viscosity. That means it can flow forever without any friction, without losing any energy. That is the new stage where the cosmic drama plays out. Okay, so in this model, they call it the gyro-sea. Massive things, like stars and planets, they don't pull stuff towards them with gravity. Instead, they act more like sinks or drains in this superfluid. They're either consuming it or pushing it out of the way. And what that does is create a low-pressure area around them, a depletion zone. And then the higher pressure of all the surrounding space literally pushes other objects inward, towards that low-pressure spot. So, let this sink in. The key takeaway here is that gravity isn't a pull, it's a push. It's an emergent force that comes from pressure differences in this cosmic fluid. You know, it's a lot like Archimedes' principle, how buoyancy pushes an object up in water. We're talking about a fundamental ground-up rethinking of the most familiar force in our lives. Now, that's a really cool idea, right? A beautiful picture. But the real question is, does it actually work? Let's get to the evidence and see how this whole fluid dynamics model stacks up against the thing that started this whole mess, those crazy galactic rotation curves. First up, and this is a big one, is a truly stunning prediction. The theory takes the Hubble constant, the speed at which our universe is expanding, and from that alone, it derives a fundamental acceleration value completely from scratch. And get this, that value it spits out perfectly matches the exact acceleration where galactic rotation speeds start to go weird. In the standard models, you just have to plug that number in because it's what we observe. But here, it's a natural consequence of the model. That's huge. And here is the real payoff. Take a look at this graph. That gray dashed line, that's what old-school Newtonian physics predicts based on the stars and gas we see. As you can tell, it fails spectacularly. Now the black dots, that's the real data, what we actually observe in a galaxy. And that solid red line? That's the prediction from the PMG framework. It's a perfect match, a beautiful fit to the data. And it does it all without needing a single imaginary particle of dark matter. Okay, so those results are wow.
They're incredibly compelling, but, good science means we have to be honest and take a hard look at the hurdles. No theory, especially one this new, is perfect right out of the gate, and this one is definitely no exception.
And to be fair, the author of this framework has been totally upfront about this. Science is all about iteration, right? It's a process. Some of the earlier, more speculative ideas have actually been retracted and corrected. The goal has kind of shifted from finding some grand theory of everything to building a more careful, more rigorous framework for something called analog gravity.
So let's be crystal clear about what this thing is and what it isn't. PMG is a really powerful tool for understanding some super complex physics, especially the geometry around black holes. Think of it as an analog model. What it is not, at least not right now, is a replacement for Einstein's general relativity. It's an exploratory framework, a new way of thinking. Okay, so the biggest technical hurdle, it's this really tricky mathematical problem called the conformal factor. Basically, for this superfluid idea to perfectly mimic Einstein's theory of gravity, the fluid and any particle moving through it have to behave in a very specific coordinated dance. The problem is, right now, trying to make that dance work creates a velocity mismatch. It introduces a kind of drag force on massive particles, like they're moving through cosmic molasses, and we just don't see that in the real universe. So a really important piece of the puzzle is still missing. And it doesn't stop there. There are other pretty big hurdles to clear. For instance, if space is a fluid, that kind of implies there's a rest frame for the universe, which is tough to square with special relativity. We also don't have the exact equation that tells us how mass creates those density dips in the fluid. Plus, we need to explain why gravitational waves don't seem to spread out as they travel, which you might expect in a fluid. These are all significant, very open questions.
So you might be thinking, okay, with all these challenges, what's the point? Why is this framework even valuable right now? Well, it's worth pursuing because it gives us a totally new lens to look through, and it actually points a clear way forward. Probably its biggest strength right now is how it acts as this incredibly intuitive river model for black holes. Just picture space-time as a river, and it's all flowing towards a giant drain. The event horizon, that's simply the point in the river where the current is flowing faster than the speed of light. It's the point of no return. This simple analogy makes the mind-bendingly complex geometry of a black hole suddenly so much easier to grasp. And this is really why this matters. All those problems we just listed, they haven't been hidden away. They've been laid out explicitly, not as failures, but as an open invitation. It's basically a treasure map for other physicists, highlighting the exact spots where the next big breakthroughs could be waiting. So, what's the big takeaway here? It's a whole new perspective. PMG gives us a rigorous way to connect the expansion of the entire universe directly to the dance of a single galaxy. It solves that nagging rotation curve problem without needing dark matter. And maybe most importantly, it gives us a clear path to explore one of the deepest questions in all of physics. How does the very geometry of space-time emerge from the stuff that's in it? So the path forward is really an exploration into a completely new picture of reality. And it leaves us with this incredible question to chew on, one that really challenges our most basic assumptions. Could it be that the fabric of the cosmos isn't an empty void after all, but a flowing liquid? And that gravity is just the currents within it?